Alright, this is the second video on radicals. So let's look at this. We want to simplify radicals, and what we're going to do in this video is we're going to use this property here that says the nth root of a times b is equal to the nth root of a times the nth root of b. So if we have factors under the radical, we can split them up into separate radicals as a product of two radicals. So here we want to simplify the square root of 12. Well, 12 is not a perfect square root, but it has a factor that's a perfect square root. And when we're simplifying radicals, we can't have a perfect power under the radical. So what we're going to do is we're going to rewrite 12 as 4 times 3. So this is equal to the square root of 4 times 3. And then we're going to use this property here that says we can rewrite this as the square root of 4 times the square root of 3. And then the square root of 4 is 2. 3 is not a perfect square root, and it doesn't have a factor that's a perfect square root. So our final answer is 2 square roots of 3. Alright, let's look at this, the cube root of 54. Well, 54 is not a perfect cube root, but it has a factor that's a perfect cube root. So we can rewrite 54 as 27 times 2. Okay? And then I'll use this property that's the cube root of 27 times the cube root of 2, and then the cube root of 27 is 3 times the cube root of 2. And there's our answer. Let's look at this, the fourth root of 80. So the fourth root of 80, it has a factor that's a perfect fourth root. We can rewrite 80 as 16 times 5. So this is the fourth root of 16 times the fourth root of 5, and the fourth root of 16 is 2 times the fourth root of 5. Alright, let's take a look at this, square root of 4y. Well, 4 is a perfect square root, y is not. But we can rewrite this as the square root of 4 times the square root of y. And then the square root of 4 is 2 square roots of y. Alright, let's take a look at another one. Okay, 3 is not a perfect square root, but y to the 8th is. And one thing I do need to mention, all the variables represent positive real numbers. Okay, we'll get into in later videos, we'll talk about if the variables could be negative when the variables are any real number, but for right now they represent positive real numbers. So this is the square root of 3 times the square root of y to the 8th. And then this equals, well, square root of 3 is not a perfect square root, but y to the 8th is. 2 goes into 8 4 times, so that's y to the 4th times the square root of 3. Let's take a look at some more. We have the square root of 20x cubed. So let's simplify this. So 20 we can rewrite as 4 times 5. And x cubed is not a perfect square root because 2 does not go into 3 evenly. But x cubed can be written as x squared times x. Okay? Because remember, when we multiply, we add exponents. So x squared times x would be x to the third. So what we do is we can just, instead of splitting it up like we did in these problems, writing them as a product of radicals, what we can do is we can just go to each term. So we have the square root of 4 is 2. The square root of 5, that's not a perfect square root, so it's going to stay under the radical. And then x squared, 2 goes into 2 one time, so the square root of x squared is x. And then x is not and then the x under the radical is not a perfect square root because 2 doesn't go into 1 evenly, so it's going to stay under the radical. So my final answer is 2x times the square root of 5x. And there's my answer. Alright, let's look at this one. Alright, so I've got the cube root. Okay. So does 40 have a perfect cube root? Well, 40 can be written as 8 times 5, and then a to the 8th. Well, 3 doesn't go into 8 evenly. Well, what if I make this a to the 7th times a? Well, 3 doesn't go into 7. Well, instead of writing it as a to the 7th times a to the 1st, what if I write a to the 8th as a to the 6th times a squared? And see, 3 will go into 6 evenly. So I'll rewrite the a to the 8th as a to the 6th times a squared. So my answer is the cube root of 8 is 2. Cube root of 5, that's not a perfect cube root. 3 goes into 6 2 times, so that's a squared. And 3 goes into 2, it doesn't go in there evenly, so that's not a perfect cube. So the 5 and a squared stay under the radical. 5a squared. And there's my final answer. Alright, so what about this one? The fourth root. Well, 48 is 16 times 3. 16 is a perfect fourth root. A to the 4th is a perfect fourth root, so we just leave that as a to the 4th. And then b to the 11th, 4 doesn't go into 11, it doesn't go into 10, it doesn't go into 9, but 4 will go into 8. So we can rewrite b to the 11th as b to the 8th times b cubed. Okay. Because 8 plus 3 gives us the 11. So now I have the fourth root of 16 is 2. Fourth root of 3, 3 is not a perfect fourth root. 4 goes into 4 once, so that's a. 4 goes into 8 twice, so that's b squared. 4 does not go into 3 evenly, so the 3 and the b to the third stay under the radical. Okay, and that's the fourth root of all that. That's a 3 there. And there's my final answer. Alright, let's look at this. Alright, here we have the quotient rule. So here, if I have a fraction under the radical, I can split it up. So let's look at this, the square root of 25 over 9. Well, this is equal to the square root of 25 over the square root of 9. And the square root of 25 is 5, the square root of 9 is 3, so our answer is 5/3. Okay, what about this one? This one's already split up, but square root of 15 is not a perfect square root, and it doesn't have a factor that's a perfect square root, and neither does 3. Well, in the first problem, I went from this to this. Well, in problem number 2, I have the right hand side over here, and I notice that 3 will divide into 15 evenly. So I'm going to rewrite this into this form over here on the left hand side. So this is the square root of 15 over 3, and 15 over 3 is 5, so I get the square root of 5. Because remember, we can't have a radical in the denominator. And we'll talk about rationalizing the denominator in a later video. Alright, here I have the cube root of x to the 21st over y to the 6th. So I'm going to split them up. So I get the cube root of x to the 21 over the cube root of y to the 6th. And the cube root of x to the 21, 3 goes into 21 7 times, 3 goes into 6 2 times, and so I'm left with x to the 7th over y squared. Alright, let's take a look at a couple more. Here I'm going to split this up, so I get the square root of 50 over the square root of 49. So let's simplify the square root of 50. So that's going to be the square root of 25 times 2. Okay, simplifying it like we did in the first problems we worked in the videos. And then the square root of 49 is 7. So this is equal to the square root of 25, which is 5, times and then the square root of 2. 2 is not a perfect square root, so it stays under the radical. So I get 5 square roots of 2 over 7. Let's take a look at another one. So I'm going to split this up, so I get the square root of a to the 5th over the square root of b to the 8th. So I'm going to simplify. So the square root of a to the 5th, a to the 5th is not a perfect square root, but it does have a factor that's a perfect square root. So I'm going to rewrite a to the 5th as a to the 4th times a, and then b to the 8th, well, 2 goes into 8 4 times, so that's just b to the 4th. And then up here in the numerator, well, 2 goes into 4 evenly, but 2 does not go into 1 evenly. This a here has an exponent of 1. 2 does not go into 1 evenly. So 2 goes into 4 twice, so this is going to be a squared, and then since a is not a perfect square root, it stays under the radical, over b to the 4th. And that's my final answer. And this is the second video. If you want to see more radicals, you can watch the next video. And that's all for this one.